Today we're going to be talking about some keywords that we've already looked at before, and some we've looked at in a little bit of depth, some we haven't. But the idea is we're going to be looking at entities, attributes, and relations, all right? We talked about entities and attributes the other day. We'll look at them again in just brief detail, but our main focus here is relations, all right? So the big deal here today is we're going to be looking at what exactly does it mean to be a relational database. We kind of have seen this already, right, in the past couple lectures. What if you could take a stab at defining that? What would you say a relational database is? Anybody? Exactly right. A database where the tables are related to each other in some way. Generally, how are they related? What makes them related to each other?
Stored in memory.
Very good. Yeah. So the idea is one table will have one field that has this exact same data that's in another field, right? So we have, for example, if you remember our customer database, in there it has a field called rep num. Well, that rep num refers to the rep table, right? And the rep nums match up. Good. All right, then we're going to be, again, looking at tables, records, and fields, but let's just start with the basic definitions here. And it's exactly what Elvira said. It's almost as if she read my notes there, which is database with related tables, right? What does related mean? We'll look at that a little bit more in a few minutes. There's another term you'll hear instead of table, and that is a relation. A table is also known as a relation. It's another way to say table. And that is a word that is used in the real world, in the industry. You may hear people use that word rather than the word table. There's another word that's used for record that I never use, but it is in formal documentation. You'll see it in the book all the time. Anybody know what it is? If you've read the book, you might know. Tuple, yeah, very good. Tuple, okay? So we're not really going to use that term in this class, but you should know about it. But the other one is a row, right? We look at the database, and it's a table, and it's full of rows, and each row is a record. We talked about that the other day as well. And then the last one, a field. Another name for a field is a column or an attribute. These are all things we looked at the other day. I just wanted to put them here together so you can kind of see them and think about them, all right? And again, let's just briefly, we're not going to spend a lot of time here because we did this exact same slide the other day. How do we feel about this idea of what an entity is? What questions do you have about that? What is an entity? I was going to put my hand over the screen so you can't see it. Don't think that'll work though. What's an entity? Yeah. And how does it relate? You're right, of course, because it's right there on the screen. But how does that relate to a database? What part of the database is the entity? Typically the table, right? Now, oftentimes, like for example, the orders table, I should say the orders, the purchases are an entity in the TAL database, but in order to represent that entity, you have the orders table and the order line table, right? So sometimes you'll need more than one table to represent one entity. But what are the kinds of entities we see in most companies? What are those things? Remember those four things we talked about the other day? Customer, employee, yep. Well, yeah, item, product, and what did you say?
I said stock.
Oh, stock, yeah, the item, the product, yep, good. There's one more. I just said it. The orders, yeah. So it's the people involved, which is usually two people, right? The customers and the employees, and then the purchasing of the products, and then the products themselves. Good. Okay, and let's remember about attributes real quick. What are some attributes of that car on the screen there? Weight, yeah, sure, that's an attribute. What else? Model, make, year, anything that can describe it, right? So if I were making a database with some tables that dealt with cars, all those might be fields in the database. Okay, good. All right, so that should be a review from the other day. New stuff, data types. In general terms, there are three data types, okay? Programmers, you should be somewhat familiar with this if you got a background in programming. But the three basic general types are text, numbers, and dates, okay? Each one of those has multiple subtypes, and we're interested in a handful of them, okay? So the text types, look on the screen there, there's a bunch of them. There's chars, variable characters, you'll hear them referred to as varchar, varchar. You'll hear char pronounced as car. I prefer char and varchar, all right? There's tiny text, then there's text, medium text, you can read the list there. But each one of them can hold a certain amount of data. All right, and we're going to kind of put those up on the screen here. the characters and the variable characters can both hold a maximum of 255 characters. Now, when you build your table, you choose how many characters it can hold. You remember seeing in some of those records where it says char parenthesis 15 or whatever? That means that that can only hold 15 characters at the most. So what's the difference? Anybody know the difference between a char and a variable character? The difference between the two is this. If I use character, then the memory that's blocked out for that field will be enough to hold 15 characters, if I'm putting 15 in parentheses. If I use variable characters, it will not block out enough for 15. It will block out however much it needs based on what's actually put into the field. So let's look at an example of this here. Let's open up a notepad here. You guys see that okay? Yep. So you've seen that we had, like, in one of our tables, first name, and it was character 15, right? Okay, we could also do this, variable character 15. This one right here on the first row, it blocks out whatever amount of memory you would need. So memory for 15 characters, okay? This will block out memory, blocks out memory for up to 15 characters. So what determines which one it uses? Here's the basic idea. If the name in the field is, let's just take some random last name, I don't know, like Stone or something, I don't know. If it's Stone, if I was using line 1, first name char 15, and the value stored in the field was Stone, even though I'm only using 5 characters, it's still, the memory blocked out 15 characters, however much memory that is, okay? If I were using line 2, instead of it blocking out 15, it's only blocking out enough to hold 5 because that's all it's going to use, right? A character blocks out all the memory whether you use it or not. A variable character will block out how much it needs for that specific record. Make sense? So if the next record was, Tom's last name, then it's going to only block out 3, unless I was using a character. Right? Did I spell it right? Hopefully. Unless I was using a character. If I were using a character, then it would block out 15 completely. But in this case, it would only block out 3 if I was using a variable character. Make sense? Okay, fabulous. Back to the thing here. All right, next up we got tiny text. And regular text, medium text, long text. This is how many characters these things can hold. And these are actual characters. Like I can put 65,000 characters. I can have a word or a sentence or a paragraph or a whatever that is up to 65,535 characters long if I use a text, okay? And you can see the different sizes there. So what are some applications? Why would you pick one over the other? Why not just use long text every time? It can hold up to 4 billion characters, is that right? 4.3 billion? Why not use long text for everything? Yeah, memory, yeah. So which one's more efficient when we get back to these guys? A character or a variable character? Yeah, that's a great answer, by the way. It depends. That's always the answer when it comes to memory. It depends. It's crazy, yeah. Because in one scenario, the first one where it's blocking out 15 or whatever, 25 or whatever every time, that could be memory intensive, but it might be just as memory intensive to have to calculate on the fly with the variable character how much memory should I block out every time. So the answer is it depends, right? And you can, when you get into the real world, you can run, what do you call them, like efficiency tools and stuff on your database and see which would be a more effective way. All right, so these kind of things, what kind of fields would you store in here? What kind of data would you put in there? Probably not going to make a text field for a name, right? Nobody's name is that long. Yeah, a description of something, or maybe you're building a blog, and you're storing the blog posts or something like that. That might be a good case for that. Okay. Then we have this other thing that's called a blob. And you got regular blobs, medium blobs, and long blobs. Notice the difference here. They block out a certain amount of memory, 65,000 bytes, not 65,000 characters, 65,000 bytes. Okay. How many characters can that hold? A lot. I'm not going to calculate, but it's a lot, right? Okay. Okay. So again, this is actual bytes of memory that can be blocked out. So you know exactly how much memory is being blocked out in this case. And blobs are just what it sounds like. It's just a blob of stuff, like letters and numbers and just a big blob of data, okay? I usually don't use blob. I'll typically use text for my databases. Then we have enums and sets. We're not going to spend too much time on these. If you're from the programming world and you know what an enum is, it's kind of the same thing. It's a set list that they can choose from a list, okay? But we're not going to use those in this class, so don't worry too much about them. If you want to know more about them, we can maybe talk about it after class or whatever, but it's also covered in the book. But we're not going to focus too much on those, all right? But those are all the text types. There's a bunch of them. When you create a database, which we will be doing in code soon, not today, but in a couple class periods, you will be using commands to create these types of fields, and you have to know what data type you want to use. Next up, the number types. Notice there are two types of number types in there. Can anybody see what the two differences are? There's just two categories there. Can you see it? Yeah, floating point and whole numbers, right? The first 1, 2, 3, 4, 5 are just integers, right? They're tiny int, small int, medium int, and big. In the programming world with Java, you have, what is it? I don't remember them anymore, man. You think, large int, what are they in Java? Long, short, that's what they are. Long and short, and there's byte, right? Sorry. Anyway, this is why I don't teach 1410 anymore. I forget all this stuff once I'm gone. All right, anyway, but we can also see how much memory this will take up, right? Now, a tiny int, this isn't memory here. This is what number it can store. It can store the number 0 or the number 1 or the number 2 all the way up to 255. Small int can go 0 to 65,000 and so forth down the line. A big int can store, what is that, 18 quadrillion? That's a big number. That's a big int, right? Okay? The other ones are floating points, and they're basically small, medium, and large floating points for the most part, right? Now, the weird thing about the decimal here, as you can see, if you use the decimal keyword, it's a double, but it's stored like a string, okay? And what's a string? Just it's characters, right? Okay. So data types, text types, and number types. Any questions about those? Good? Okay, date types. That's the best picture I could find, guys. It was either that or a calendar. So, all right. So there's more than one date type, believe it or not. There's just one called date, then there's one called date time, and then a time stamp, and then time and year. So let's see if we can figure out, without me showing you, what do you think date just stores? It's not a rhetorical question. Just a date, right? Yeah, year, month, and day, right? How about date time? Date time, year, month, date, hour, minute, second, right? So what does timestamp store? No, it actually does store the whole date. It stores exactly the same thing as date time does. What's the difference? So the difference between the two, the timestamp is when a record is entered, then the timestamp will automatically put a timestamp on it right then. Whereas a date time is more like storing a time that's already happened. Like I want to store, or that's going to happen. I want to store the date and the time of your flight that's coming up. The timestamp is what time is it right now when you entered this record right this second. Bam, it puts a timestamp in there. Time just holds hours, minutes, and seconds, and year just holds the year. So you can see the dates right there. That's the format that they'll be in, right? And then the time is hours, minutes, seconds, and then the year can be 2 or 4 digits. All right, any questions about these data types here? We good? So these are the ones we're interested in. Look how interested he is. He's very interested in these data types, okay? All right, so these are the ones we care about for this class, but this class isn't the entirety of what you'll do as a database programmer, right? But for this class, these are the 4 that we use in all of our tables. But in the future, you will see those other ones for sure. Okay, so we care about chars, decimals, dates, and integers, right? Let's take a look at the format for these. If I'm going to create a char, when I create my table, that's the format we will use. We'll say char, parentheses, some value, 15 or 20 or whatever we've seen so far. 2 when you're dealing with a zip code or a state field, okay? Decimal looks like this. You write decimal, parentheses, size, comma, D. The size is how many digits the whole number can be, the complete number. D is how many of those numbers are to the right of the decimal. So if I would only be able to store a maximum of 999,099.99, what would my format there be? 6, comma 2, right? That's 6 digits total, 999.99, that's 6 digits total. Then D, 2 is to the right of the decimal. Very good. And we'll see all this in action when we build the tables. Date, you just put date. When you're creating a field, you're just going to type create table, give it a name, the field name, and then just say date. Same with integer, okay? When we build our tables, and we will be doing that, I promise. It won't be for another couple lectures, but we will be doing that. That is how that'll work, okay? You'll use those 4 fields, and we'll learn all those commands a little bit later, okay? Questions on that? Feeling all right?
Oh, question.
Yeah.
So in the earlier slide, you showed date as year first, then month, then day. Is that the format?
Yeah, when you enter the data in, correct. Yeah, and in fact, let's do that real quick. So when I'm inserting into the database, I would insert, like today's date would look like this, 2019/05 or -05-22, right? It would look like that. If I were going to do it to the minute right now, it should be, hours would be 19:32, and I'll make up 22 seconds or whatever. Look like that. Okay. So use the military time there. Okay. So data types out of the way. Let's go back and look at the databases a little bit more in depth here. Let's take a look at the TAL database. What are the TAL entities? And we've talked about this before. It's the 4 things, right? It's the customers, it's the employees, it's the sale. A sale is a tangible thing, and a product is an entity, right? Then notice the sales, it has 2 date tables that manage everything, all right? So take a look here. This is the layout of the rep database, the structure of it, all right? And notice what we have here. Now that we know a little bit about data types, let's see if we can understand this a little bit better. So when this table was created, we created a field called repnum, or you will do that eventually, and we told it to be 2 characters, and that is the syntax right there. Down here for commission, we told it to be a decimal, and it's going to have 7 characters total, and 2 to the right of the decimal. So what's the largest number that can hold? 99,999.99, right? Very good. Anything more than that? That's like your Y 100K bug, whatever, right? Okay. Notice this one here, rate. Also decimal, 3, comma 2. So what's the largest thing that can hold? Largest number that can hold. Think about it. 3 digits total. 2 of them are to the right of the decimal point. So how many are to the left? 1. So what's the largest number it could hold? 9.99. Yeah, 9.99. Yep. 9.99. Why so small? Yeah, it's your commission rate, right? So most people's commission rate is like 0.1 or 0.2 or something like that, right? Okay, good. Notice this other thing here. This is the formal notation for representing a table. Now there's one little piece missing we'll learn about later, but this is the formal notation. So what have I done here? What's in that formal notation? What have you done, Jeff? What are you looking at there? Yeah, it's just the name of the table and then the field names in parentheses. That's all. Nothing fancy, okay? The next thing that you'll learn, we'll do it later, but when we learn about primary keys, which we're not talking about today, but whatever one of those fields is what's called a primary key, it will be underlined, okay? Right now I'm not doing that because I don't want to mess with the key stuff today because that's a whole other subject on its own. But in the future, you will learn about the primary key, and that will be underlined in that notation. But other than that, that notation is the formal notation, okay? All right, let's look at this table here. Get back to me. There we go. Same thing, right? We just have the formal notation there, the customer with the fields and the parentheses. And what data types do we have? We just have characters and decimals, right? Same stuff we're used to. And in fact, I'm pretty sure that none of the fields in any of the tables in this database use the integer data type. There's a couple things that I'm going to do that are not in the book that will use that. But for what's in the book, we only use char, decimal, and date, and that's it. Okay? And here we go, char and decimal again. And note the proper notation there, the top for the item table. And here we have one we're using date, right? The order date. That's using the date data type. And notice the way it's laid out. There's nothing else that you have to put other than date. That's it. Okay? And again, I'm going to teach you how to create this very thing later. Okay? Maybe we'll look at a small example today. All right? But then this, again, when we're going to create a character, it's char and then some value. Now this order number, 5 characters. So if we're using, what's the most amount of possible numbers we can put in there, possible order numbers we could put in there? It's 5 characters, and the character can be a number or it can be whatever.
Well, it'll be way more than just
Yeah,
99,000.
you're exactly right. You're going where I was hoping you'd go. So if it were just 5 numbers, then the biggest number would be 99,999, right? Which means when we got to our 100,000th order, we don't have anywhere to put it in our database. But if order numbers have a letter in them, or a last name, or like it's part of your last name, or maybe my order number will be ST123 and then ST1234 or whatever, then you can hold a lot more data because you have the entire alphabet. And if you want to put characters in there, like a period or an underscore or a dash or whatever, you can put all those things in there. So you can hold a lot with a 5-digit character. But when you're building a database, these are the kind of things you need to think about. If you get in a situation where you're creating order numbers and you ask the person, the boss, the guy or girl who owns the company or whatever, what exactly do you want, what do you want your order numbers to look like? And their question might be, why do you care about that? And my answer will be, because I want to make sure your database is future-proof, right? So if your order numbers are going to be strictly just numbers, then we need to do a different thing here. If you want to be able to have a letter in your order number, I need a different type of field. These are the kind of questions you got to ask people, right? I promise you, if you do your job right as a database programmer, when you're interviewing people, you will be the most annoying person that works for that company. It'll drive them crazy, okay? It's just part of the job, okay? All right, next up, order line. Notice decimals and chars, right? Same thing, okay? Let's take a look at this now. This is what's called an entity relationship diagram, which we are going to spend one entire day on that subject alone, or one entire lecture. It might be half a day, but one entire lecture on this subject alone. But just briefly, look at what's going on here. In the past, you have seen this way to represent a table, right? With the little, digital or like plain old, let me just open up mine here real quick. Just a plain Jane looking interface, right? Describe a city, okay? That's just the DBMS's way of displaying this in a useful, human-readable way. Well, there are also tools out there that will let you display it like this. Workbench is one of those tools, which we will learn towards the end of the semester, okay? Workbench is one of these tools. This was made in Workbench, but it's the same thing. It's listing all this stuff right here, right? So this table here, look at it. This is the order line table. If I come back to here, well, here's the order line table, and what do you see? It's the same things there, right? It's order num, and it's a char 5. Item num, and it's a char 4. Num order is a decimal 3, and then the quoted price is a decimal 6.2, right? That's exactly the same thing that we're saying right there. It's just a more graphic way to represent it, okay? Also, you'll see we have all 5 of the tables being represented here. Every single towel table, right? Every towel table is here, and you'll notice there's a line drawn between them. This line represents the relationship between the tables, okay? So you can see here, we have this little dude right here, there's a 1 right there, and can you guys see what that is? That's an infinity symbol. In our world, infinity means many, right? Some unknown number of many. This type of relationship here that I have the two boxes around is a one-to-many relationship, okay? Let me get out of this real quick. I'll show you how to write that. Okay, that is a one-to-many relationship. There are three types of relationships in a database: one-to-one, one-to-many, and many-to-many. All right? What exactly does that mean? What do you think that means? One-to-many.
Is it that the one item in the one table could be paired with multiple items in the other?
Yeah, so this one thing here can have many things it's related to in the other table. So, for example, let's go back to the tables here. Let's look at one that's a little easier to wrap our heads around. Let's go with the customer and the rep, okay? Does it make sense that one rep could have many customers, right? You know, rep number 7 has customers number A1, A2, and B7, right? That makes sense. So they have a one rep to many customers. This line is actually drawn from which fields tie them together. It's the rep num and the rep num, right? The rep num in the customer table refers to the rep num in the rep table. Dig it? All right. So that's a one-to-many relationship. Notice nowhere on here do you see a one-to-one or a many-to-many. Nowhere do you see an infinity leading to another infinity or a one leading to another one. Yes, sir.
You've got one implied between.
Yes, you're getting that, you're jumping ahead, but yeah, you're right. Very good. Good observation. Okay. So which one's implied? A one-to-one or a many-to-many? Very good. Yeah, we'll talk about that in a second. Very good observation. Let's think about a one-to-one scenario. Let's talk about the customer rep thing. That's a one-to-many, but can one customer have many sales reps? Yes. The answer is the same answer you gave a minute ago about memory, which is? It depends. Can a customer have multiple reps? It depends. It depends on what?
The company's rule.
Yes, that's a business rule. That is not a computer rule. That's not a database rule. That's a business rule. Okay? So the business may say, no, we do not want one customer to have multiple reps because that, then that's, what's the phrase? Too many cooks in the kitchen or whatever, right? They just don't want to confuse people, right? And so we want to make sure that we have very clear, and this is just me speaking as the theoretical company owner of Tal Entities, Tal Database, or Tal Distributors, whatever it's called. I do not allow my customers to have more than one rep. The end. Therefore, you, the database programmer, will program it that way, right? So in that scenario, it's a one-to-many relationship. One rep to many customers, but not the other way around. Okay, one-to-one. We do not have that in any of our databases. We rarely have them. My whole point a minute ago with all the databases I programmed, the hundreds or thousands or whatever, I've never used a one-to-one relationship. They're very rare. Can you think of a scenario where that might be the case? The one that I think of is it's a company that has like employee automobiles, like a car for your employees, and they do not want employees to share a car, right? Like this, every employee gets their own car, and that's a one-to-one relationship. One employee gets one car. One car belongs to one employee. You can't have one employee that has two company cars. You can't have one car that has two employees that drive it, unlike the Navy and their beds in the submarine. Do you know about that? On submarines, 3 people to 2 beds. It's called hot racking. There's always somebody in the bed. You have to share, not at the same time, obviously, but you always have to share with 2 other guys, two beds, 3 guys. Not the same with the cars. Anyway, sorry.
So with that, would it be like employee to VIN number? Because the car could be multiple of the same type of car?
You'd have something to identify the car in the car table. You'd have a car table, and it might be the VIN number. It might be just the company's ID for that car, like that's car number 1, that's car number 2. But yeah, it would be a unique record, and then you'd have a table that maybe in the employee table, there'd be a car ID field, and it would say, yeah, employee number 7 owns car A. Employee number 8 owns car B, and so forth, yeah. Good. Sorry about the Navy stories. All right, anyway, whenever in the Navy, whenever there's a guy that's been in for a long time and come to do a lecture or something to all the new guys, that always chant, C story, C story, C story, because they always have these crazy C stories. Anyway, okay, any questions about what's going on here? Let's talk about the many-to-many if there are no questions. So one-to-one, we good? We probably won't use it in this class. You may rarely use it in the real world. One-to-many is the most common by far, where you have one thing that can have many other things. Think about like a music album. Uh-oh. Anybody know this thing on the screen here? Is that legitimate? That just keeps coming up on my screen. And I keep closing it, so I don't know. Without clicking on either of those buttons, I don't know what's going on there. Okay, I don't know. Anyway, so one-to-one, probably won't use it. One-to-many, most common one. And again, I was gonna say, think of like a music album. You can have one album that has many artists on it, right? You can have one artist who has many albums. So if you were matching up albums and artists in a database, that would be a many-to-many relationship. Could be, right? Make sense? One artist to one song? Nope, one artist can have more than one song. One song to one artist? Nope, songs can be co-written, right? So that's probably a many-to-many. So it's pretty common, but one-to-many is definitely more common. So you said there's a many-to-many here, John. Where is it? You're right, it's there.
Between orders and items.
Yeah.
One order can have many items, and one item can be spread across many orders.
Very good. So when you order something, you can order 5 things, right? 5 different things, right? That's totally legitimate. And any one thing from an item table can be ordered by multiple people. So orders can have multiple items on them, and items can be on multiple orders. So there is a many-to-many relationship. However, if you're going to make a many-to-many relationship between 2 tables, we create what we call a bridge table. There's another name for it, which escapes me at the moment. It's in the book. But what is it? Through table, that's not the one I'm thinking of, but that's another term for it, yeah. There's one other one. Don't quote me on this, but it's something like a conjunction table or something like that. But bridge or through, those are good ways to kind of describe what's going on, okay? So that's why we have an order line. Now think about the order line. What's on the order line? In fact, I think in the previous slide we can see what's in the order line. There's an order number, there's an item number, there's a number ordered, and then there's a quoted price. Those are the only fields in the order line table. Can one line on an order, on like you're looking at your printed out invoice, can one line have multiple order numbers? It cannot. It cannot have multiple item numbers. Well, what if I wanted to buy 3 Rubik's Cubes? It's the same item 3 times. That's why you have the quantity field, right? The number ordered field. It's still one record, okay? So you create a bridge table that bridges the 2 things together. Question?
So when you have a many-to-many relationship, do you have to have a bridge table?
If you want to be a proper relational database, if you have a many-to-many relationship, you do need this bridge table. And the bridge table, so if this bridge table weren't here, then you'd have multiple item numbers on multiple orders, and you'd have multiple orders on multiple item numbers. I know you guys are still new to imagining what a database might look like, but try to imagine how you would do that in just the 2 tables without that bridge table. It'd be really crazy, messy, ugly, and I don't really know of a way you could do it, without having like duplicate records throughout the database. So this bridge table shrinks it up, right? So think of it as one of the other databases from the old book had a bookstore, and it matched up book authors and the books themselves. And so some books had multiple authors, and obviously authors have multiple books. So there was a book author table. What was it? It was just a list of an author ID and a book number, an author ID and another book number, an author ID and another book number. You might have author ID in there 50 times because he has 50 books. You might have book number 7 in there 3 times because it has 3 authors, right? Question?
No, I'm just trying to think.
Oh, yeah, that would be a good visual there. I still have that old database. I could pull it in and show it to you guys. All right, any other questions about this idea here? Okay. Let's look at the colonial entities. Again, it's the same idea, right? We have a customer and an employee. That's the guide in this case. We have the product, which is a trip in our case, and then we have the sales stuff, those 4 main things, where there's a reservation and a trip guide, and that's another scenario we're going to see a many-to-many relationship. Okay, we're just gonna skim through these because we've already seen this basic idea here, but there's the formal notation at the top. And there it is again, and these slides are available to you as well, and this video will be too. All right, so stop me though if you see anything you want to look at. Notice all the way through though, it's just characters, decimals, and dates. That's all we're using. Those are the three data types that we use, okay? So let's take a look at this. This is the same thing. How are these tables related? Well, the guide table relates to the trip guides table through the guide num, and you can see that's where the line is drawn from. And then the trip guides is related to the trip table, and they see that's where the line's from. And looking at this, where is, John, you don't get the answer, where is our many-to-many relation? Yeah, it's the trip guides table, and you'll know, this is a pretty standard naming convention. You can call it whatever you want. Call this table Beavis if you want. But typically, you will see, that's what I call everything when I don't have a name for it. Typically, you will see, especially in the MySQL world, they'll name it like this. They'll name it this table underscore that table, or vice versa. Guide underscore trip, or trip underscore guide. And you'll see that name right there. That's typically going to be your bridge table. Usually, that's the standard naming convention. A lot of times, the other one I'll see is they'll say trip underscore TO underscore guide, right? Trip to guide. Or trip, the number 2 guide, no underscores, just trip to guide. I see that a lot as well, okay? All right, looking at that diagram, how do we feel about it? Do you have warm fuzzies? All right, next up, let's look at Solmaris. This is the third final database. And now this one's a little different. It doesn't have the typical 4 things: customer, employer, or employee, product, and purchase. But it has a lot of those components. We do have the owner, which is the customer. We do have the location, which is not, there's no sales reps represented there, but that's where the condo is located. We do have the product, right? That's the condo. And then we have the maintenance in this case, which is kind of a sales type thing. They can buy maintenance packages or whatever, okay? But again, I'm just going to blaze through the tables. We've seen them all already. You can see the formal notation in there. Notice again, only decimals and chars are being used. Chars, 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 decimals and chars, decimals and chars, okay? Same thing all the way through. And then here's the entity relationship diagram. Where is the many-to-many relationship on here?
Service category, common.
So service category to condo unit. So one service category can be applied to many condos, right? And one condo can have many service categories being applied to it, okay? But it's a little tricky here because the service category is really not a condo thing. It's not really connected to the condo itself, okay? You would never, if we were to get rid of the service request table there in the middle, you would never really have a service category to condo request, to condo unit bridge. The service category has nothing to do with the condo itself. It has everything to do with the actual service request. So it really isn't a bridge table in this scenario, okay? This is just, and when we learn about normalization, you'll see why this table came in handy here. This has a one-to-many relationship with this, for sure. This over here is just a little bit more information about this. It just adds some detail to this. Okay, that's all that's happening there. So this is not really a many-to-many there. So that being the case, can we see a many-to-many anywhere else?
Between owner and location.
All right, let's look at that for a minute. So we have owner going to the owner num in the condo unit, and we have location going to location num in the condo unit. Could the owner have many locations? Sure. Can the location have many owners? Sure. Looks like a many-to-many relationship, right? And it kind of is. It's a little bit trickier in this one. This one could probably be done in a one-to-many style, or I'd have to think about that. This one's just a little iffy. It is kind of a many-to-many relationships. But the real thing is, you wouldn't necessarily tie an owner directly to a location, right? Whereas you wouldn't say, oh, who are the owners in this location? You might, that's a business decision, you might. Or what are all the locations related to this owner? That's not a thing you really care about, right? What we really care about is this owner owns which condo. Just so happens that we need more information about the condo, like its location. So it's a similar scenario. This piece of information right here, we can learn more about it with this table, right? Location could be just stored in this table right here, couldn't it? It could. We could just have a field called location, right? And then over here, this owner, yeah, the owner definitely relates to the condo unit, but the owner doesn't really have a relationship with the location. Okay, so it's a little fuzzy there, yeah.
If you did, you couldn't control your locations unless you had a list defined on the field, right? So if you wanted to maintain a pristine list of locations, you need that table.
Yes, for sure.
Otherwise, you could have all kinds of different spellings.
Very correct, which when we get to normalization, that's exactly the problems we try to solve. Yeah, he was just pointing out that for the sake of the recording here, that if I did not have this table right here, this location table, if I didn't have that, and I just stored it in this database or in this table here, then you could have a lot of data issues, what do you call it? Inconsistent data, invalid data. There's another word I'm looking for, corrupt data. That's the word I was looking for, corrupt data. Sounds so much more dramatic when you say corrupt data, right? Okay, so you could have some issues there. When we get into normalization, we'll see how that would play out. But the real point I was getting at here is location is really just an extension of the condo unit table. It's not really trying to bridge this owner to location relationship. There isn't really one there. So I would argue there's not really a many-to-many thing going on here. Yes, maybe through the structures of the table there kind of is. But the many-to-many comes up when you're saying, I as a company want to track this thing and that thing, and this thing can have many of those things, and this thing can have many of those things, right? So this was our plan today. Review Canvas, which we did for the here in class. We didn't do that for the recorded portion of it, but learn some more vocabulary, some formal notation. You guys remember the formal notation? Table name, field names, and parentheses. We looked at entities and attributes again, just a reminder. We looked at the data types. What is a relation? Another name for a table. Yeah, another name for a table. And then types of relations, we have one-to-one, one-to-many, many-to-many, and then we're off camera, we're gonna build a database here on the whiteboard together. Okay? Any questions?